Hello everyone. Today we're going to be starting off with a new series on automata and computability. So it's basically on theory of computation, but I'll be going more into the technical and logical part rather than the theoretical part, and like how you would solve problems regarding theory of computation. So at first I'll be discussing about deterministic finite automata. So a deterministic finite automata, or a DFA, consists of a finite set of states. States are denoted by circular symbols. A finite set is this by circular diagrams like nodes in graphs. A finite set of symbols, which could be A, B, C, or 0, 1, or anything like that. A transition function. A transition function is basically from the initial state, that takes two arguments, the initial state and the alphabet, and it equals to the next state that it goes to. A start state is the one that the whole diagram, the whole DFA starts from, the state that it starts from. A set of final or accepting states are basically the states that accepts the whole DFA, the DFA language. So this is basically how a DFA looks like, this diagram here. So Q0, Q2, and Q1 are the states, and 0 and 1 are the alphabets, and the start state is Q0 and the finishing state is Q1. Uh, and the deterministic finite automata, the main thing about that is that it's finite, means it's a finite state machine. Because if you give one, if you like for every state there has to be all possible alphabets given. For example, since the alphabet given for this language is 0 and 1, so for every state there has to be all possible moves with all the alphabets used. Well, I'll explain that after I show some examples, then it will be clearer. So, and this is the transition table. So it's basically another way of representing this whole DFA diagram. So as you can see, Q0 is the start state, Q1 is the accepting state. So at Q1, when the input is 0, it goes to Q2. At Q0, sorry, at Q0, when the input is 0, it goes to Q2. So as you can see, at Q0, when the input is 0, it goes towards Q2, and when the input is 1, it goes towards Q1. So similarly, for all the other states, the same thing is done. This column represents all the states. They will not be repeated, they will always be written once, and these are the input alphabets. It could be 0 if the input alphabets were A and B, so then instead of 0 and 1, A and B will be placed here. Alright, so DFA is a five tuple it's represented as a 5-tuple. So Q is the states, number of states, sigma is the alphabet, delta is the transition function, Q0 is the start state, and F is the finishing state. So let's look at some examples. So if you're given a substring that starts with 0, if you're given a string that has the substring 0101, and it could have any number of any alphabets before and after, but it just has to contain 0101, what will be the DFA for it? So the DFA here that's drawn is there are 5 states. So 0101 has to be the substring, so 0101. Alright, but we have to DFA considers all the possible outcomes when all the alphabets are given. So for example, if 0 is given, it goes to the next state, but if 1 is given, it stays in this state as many if for example, if as many ones come, that time it will keep on moving in this state, which is the start state. So if 0 is encountered, it goes to the next state. Again, if another 0 is encountered, it will stay in the same state, because that is still acceptable. But if a 1 is encountered, then it goes to the next state, because we have to progress as we start getting this substring. So a substring could be something like 0, 0, 1, 0, 1. So that's why this is acceptable. So 0, 0, 1, 0, 1, and it's accepted. So for knowing if your DFA is acceptable or not, it's better if you could write all some example strings that would come from the DFA. For example, here 0, 1, 1 1 0 0, and it's not accepted because 0 1 0 1 is not a substring in this what you called in this string. So again, this one should be accepted because as you can see, 0 1 0 1 is here, like this part is the 0 1 0 1 substring. So before that and after that, whatever comes, we don't care, but as long as this 0 1 0 1 is there, we accept the string. So let's see if it's accepted. 0 1 0 0, then 1 0 1, and then 1. So that's how the DFA is drawn. Now in DFA, as you can see, for every state there is always a 0 and a 1 outcome. Like if it's a state A, what will happen when 1 is encountered, and what will happen if 0 is encountered. Same way, if it's a state B, what will happen if 0 is encountered, what will happen if 1 is encountered. So we have to include all the possible things that could come out if 0 and 1, if the alphabets are given are 2, which are 0 and 1, then for every state, whatever happens, whichever state it goes to, whatever is a transition function for every state, all of them have to be shown. So if you just wrote 0, if you just wrote for state B, if you just wrote that when 0 is encountered, you stay at state B, but you don't give any, sorry, if 1 is encountered, you go to state C, but you don't give any sort of explanation as to what will happen when 0 is encountered, then it's not a DFA. DFA has to have all the states, has to have all the possible outcomes. As you can see, even in C, if you're in state C, we have given the transition functions. We have given the transition arrows for each of the alphabets. For 0, it goes to state D, and for 1, it goes to state B, right? And for D also, for 0, it goes to state B, and for 1, it goes to E. So this will come as you keep on practicing on drawing in DFA. It's pretty logical. You just first, for substrings, for questions that require substrings, you always need to first define all the arrows that will go to for 0 1 0 1 and ends at the final state. And after that, whatever strings come, we don't care about it, and whatever string comes before, that is when 1 comes, we do handle it. We still keep on staying in the same state, and when 0 comes, we go to the next state. We progress as we get parts of the substring. So again, I drew the transition table for this. When it's in state A and the alphabet is 1, we go to state B, and when the alphabet is 0, we go to state, sorry, it's reversed. Yeah. So when we're in state A and we encounter 0, we go to state B, and when we encounter 1, we go to state A. Similarly, for all the other states, it's given. A star denotes the accepting state, and the arrow denotes the start state. So let's go to the next example. Even number of a set of strings which has even number of ones and 1 or 2 zeros. Even number of ones is, it could be 2 4 6 8 10, as many, like the ones will be in terms of even numbers, and it will be accepted if there are 1 or 2 zeros. Like if there are 1 0, if there's 1 0, it will be accepted, or if there's 2 0, it will be accepted. But if there's more than 1 or 2 zeros, then it will not be accepted. All right. So how do we solve this? First, when we encounter, first let's handle what will happen if we encounter 1 or 2 zeros. If we encounter 1 0, we accept it. If we encounter 2 zeros, we also accept it. So there will be one starting state. Forgot to give this arrow. Sorry. When we encounter 0, we go towards an accepting state. When we encounter another 0, we also go towards another accepting state. But if we encounter further, if we encounter more zeros, we don't go to the accepting state. This goes to a form of death state. What is a death state? Death state is something that will not ever accept the string. Like whenever you have some alphabet and it does not go into any other state, except the what you call the accepting state, then you just push the string towards a death state, right? So when you encounter 0, when there are 1 0 or 2 zeros, and we reject it when there's more than 1 or 2 zeros. So how do we handle even number of ones? So when we encounter one, we go to this state, and when we encounter another one, so we go to this state, right? So uh, we keep on exchanging position of 1 and 0 and 1 and 0. This should be, so these two conditions have to be fulfilled in order to reach the accepting state. So let's write some example strings in order to verify if our DFA is correct or not. So when we encounter 1 0 0 1, this should be accepted because there are even number of ones, and there is also there are also two zeros. So we encounter 1 0 0 1, so we reach the accepting state. Now let's go with another string 1 1 0 1 1. So 1 1 0 1 1, so we reach the accepting state again. Now for this string, there's odd number of ones and two zeros. Two zeros is fine, but odd number of ones is not acceptable. So 1 1 1 0 0, we don't reach an accepting state. Same goes for this. So 0 1 1 1 0, we don't reach the accepting state. Right, so how do we construct this DFA? We first try to fulfill one of the conditions, and then we try to join these conditions, because we have, like, these two conditions are joined by an AND. If there was OR, we don't need to relate both of these conditions with each other. And another thing we need to keep in mind, as I said before, is that what you call a DFA has, for every state in a DFA, all the possible alphabets need to be included. So for this state, let's name it A. For this state, we know which state it will go to when we encounter 0 and when we encounter 1. Same for this, let's say it's B. We know it will go to state C when it encounters 0, and when it goes to state D when it encounters 1. Again, when it goes to 0, it goes to E, and it goes to F when it encounters 1. So for every state, all the possible possible transitions are given for all the alphabets, and that's the main criteria of a DFA. So let's look at another one. Set up all strings with number of zeros divisible by 5 and number of ones divisible by 3. So there should be 5, 10, 15, 20 zeros, and 3, 6, 9 number of ones. So to the power of 5 and to the power of 3. 0 should be to the power of 5, and 1 should be to the power of 3. Right. So as you can see in this diagram, it should be a set of all the strings. So if we don't encounter these, it will still enter an accepting state. But if not, it will go towards 0. First we need to construct that for 4 zeros it won't accept, but for the fifth number of 0 it will accept. So it will keep on going in multiples of 5. So suppose there are 10 zeros. So 0 0 1 2 3 4 5 6 7 8 9 10. So it will keep on going to with 10 multiples of 5, zeros in multiples of 5, and we need to join these, because it's this whole string was made, the whole question was, in the question it was given that both of these conditions have to be met. So when the output is 1, so when there are 2 ones we don't accept it, but on the third one we accept it. So it could be like this DFA would go on in multiples of 3 for the input alphabet 1. So similarly we do the similar function and we join it, and it will keep on this will be accepted, because whatever input you give, like for example this is the input that I'm giving, so there are 5 zeros, right? So 0 0 0 0 0 and then 1 1 1, so it's accepted. Now let's go towards this. The DFA is something that you would understand, like that you would construct properly if you could jot down at least 4 to 5 examples, 4 to 5 example strings, and then test it out in your DFA, and if it works then your DFA is foolproof. So let's look at this string: 0 1 0 1 0 1 1, then 0 0. Now this was a really complicated one, and this was accepted, so this shows that how foolproof this DFA is. Now let's go towards a wrong string. So there is 4 zeros and then 1 1, so it does not enter the accepting state, so the DFA is not accepted. So this the string is not accepted, so this DFA is foolproof, and it accepts all the set of strings that are divisible by 5, and it's all the set of ones that are divisible by 3, all the set of zeros that are divisible by 5, and all the set of ones that are divisible by 3. So yeah, I hope you understood the DFA, the concept of DFA and how to draw it. And if you're given example strings, example questions, sorry, not strings, example questions, the first step would be to jot down 4 to 5 example strings that would match the question, and after that draw the DFA accordingly. If the clause is and or, if it's and, then it's then you know that both of these conditions have to be met together, and if it's an or, then they could be met individually. So when it's an and, it's a bit tougher because you have to join both of these conditions somehow and relate them somehow. And also the third rule that you should remember is that for every state, all the possible outputs have to be given. As you can see, even for this state, and all these states, the transition for 0 and the transition for 1, since the input alphabet is 0 and 1, the transition for all the input alphabet is given. Right, so I hope you understood the concept of DFA a little bit from this video, and give a thumbs up to encourage more of tutorials from Automata and Computability, and good luck.